So, as we've talked about, the model of the atom has changed over time. And one big jump in our understanding of the atom came from Niels Bohr. He developed the so-called Bohr model of the atom, which actually describes how light and matter, the atoms and electrons in matter, interact with each other. Before we can talk about a model, let's review what exactly a model is. A model is a description of how and why a phenomenon occurs that also has predictive power. And these models must be supported by a lot of scientific and experimental evidence. You can't just claim anything as a model. You must have the evidence to support that model. For example, in the model of the solar system, this model, based off evidence and observations over years and years and years, allows us to explain why the planets and stars seem to move in the ways they do. It also allows us to predict when the planets are going to be in certain places in the sky, when comets will pass by the Earth, and even when eclipses will occur. So what exactly is the Bohr model of the atom? In the Bohr model, you still have the nucleus with protons and neutrons at the center of your atom, but your electrons are now organized into energy levels. And these energy levels can be compared to orbits. So you can have an electron that is low in energy in the first energy level. So this electron is close to the nucleus. It doesn't have enough energy to move away from the nucleus, and it'll stay right here. If this electron has a little bit more energy, the electron will be in the second energy level. So it'll be in this orbit around the nucleus. A little more energy, and it'll move up to the third energy level. And even more could move up to the fourth and fifth and sixth, and so on. Now, the important thing to know about this model is that the electrons can only exist in the specific energy levels. So this electron can exist in energy level 1, 2, 3, or 4, but it is impossible for this electron to exist in between. So you'll never find the electron in between energy level 1 and 2, or between 2 and 3, or between 3 and 4. It can only be in a specific energy level. Now here's where the light comes in. So let's start with an atom like we have here, where the electron is in its lowest energy state. And whenever we have an atom that all the electrons are as close to the nucleus as possible, we say that atom is in the ground state. So the ground state is an atom in which all electrons are in the lowest energy levels as possible. But it is possible for these electrons to move to a higher energy level. And the way that this is going to happen is that our electron here has to gain some energy. To give this electron some energy, we need to hit it with a photon, a little packet or particle of light. So if I have my photon, and my photon's going to come here, it's going to hit my electron. That little squiggly line is a photon, and that has a certain amount of energy. When that photon hits that electron, the electron is going to move up to another energy level. Now, how far the electron moves, whether it just moves from 1 to 2, 1 to 3, or 1 to 4, depends on how much energy that electron has. Once the electron is in this higher energy level, we say that the atom is in the excited state. So the excited state is an atom in which at least one electron has, and we sometimes say, jumped or moved to a higher energy level. Now, as you might have learned in physics, is that things don't tend to stay at high energies. Objects tend to go where their energy will be the lowest. For example, let's say you're standing next to a desk, and all of a sudden I come in and I scare you. I come into the room quickly, I scare you, and you jump up on top of the desk. Well, on top of the desk, you have more energy. You have been excited, just like an electron. So you're excited on the top of the desk. But eventually, you're going to get tired of standing there, and you are going to come back down to the floor. And maybe if you stood there long enough, you would lay down on the ground and go to sleep. But at some point, you would come down or fall down off of the desk. Now, the same thing is true with electrons. So we have our electron up in our excited state. Eventually, the electron has to return back down to its ground state. But we have to worry about the law of conservation of energy. If the electron is going to move back down to a lower energy state, that extra energy that it got from the photon has to be released. So when our electron drops back down to the lower energy level, a photon is going to be released from that electron as it moves back down. So in that way, energy is conserved. So in the Bohr model, an electron will move to a higher energy level if it absorbs a photon and it will move back to a ground state when it releases a photon. Now, the last thing I want to talk about in regards to the Bohr model is actually the beginning of quantum mechanics. We actually saw some quantum mechanics when we dealt with a photon. Quantum just means a little piece of something. But we need to see what types of photons will be absorbed by an electron. Photons will only be absorbed by an electron if the energy of the photon is the same as the difference in energy between energy levels. So if I want to raise an electron between energy level 1 and energy level 2, the energy of the photon that has to be absorbed in this process has to be equal to the energy difference between energy level 1 and energy level 2. What exactly these energy levels are depend on the type of atom. So if I have a photon that has too much energy, more energy than the difference between these two energy levels, the photon will just go through and not interact with the electron. If the photon has too little energy, it's also just going to go through and not interact with the electron. If the photon happens to have an energy equal to the difference between, let's say, energy level 1 and energy level 3, then the electron could jump all the way to level 3. But this is also true when the electron drops back down. When electrons drop down in energy level, a photon is emitted that has the same energy as the difference between the energy levels. So this is actually what explains the colors of fireworks. The colors that you see describe the difference in the energy levels of an atom. So if the energy between these two energy levels, or any of these two energy levels, is the same as the energy of a green photon, then the light that's emitted when the electron drops back down is green. If the distance energy difference between two energy levels is the same as the energy as a yellow photon, when the electron drops back down to a lower level, a yellow photon will be emitted. We can also use this model to explain fluorescent lights. We can actually excite the electron. We can move the electron up to a higher energy level using electricity. That's why when you turn the switch on, electricity flows through the gas atoms that are in the light, so the electron jumps up. When the electrons fall back down to the ground state, the light that you see coming from the bulb is emitted.